Hello, we're going to look at chemical reactions today, just two different types, synthesis and decomposition. Hopefully you guys have watched the videos on those types, and we're going to go over a few details. Today our goals are to look at both those different types of reactions and how to figure out how they're different using only reactants. We're going to look at some similarities and differences between those two types of reactions as far as the reactants and the products go, and energy used in those types of reactions. Some vocabulary reminders before we get started. The materials that you find in a chemical reaction before you get started are called the reactants. The materials that are formed at the end of a chemical reaction are called products. Temperature changes happen in all chemical reactions. We're going to look at the vocabulary terms subscripts and coefficients on the next slide. The next slide shows the meaning of several different symbols that you might see in a chemical reaction. So if you just have a symbol, that means one atom of that type of element. So here we go. Here we have one type of element, but there's a subscript. That subscript means there's two of those atoms stuck together. Here we have the symbols of two elements together. That means there's a molecule of one atom of each of those two elements. Here is one carbon plus two oxygen atoms stuck together to form a single molecule, and the coefficient in front of CO2 indicates that you have three complete CO2 molecules. All right, a synthesis reaction is making one bigger product from smaller reactants. Frequently, those smaller reactants are two different types of elements, but they don't have to be. They could be two different compounds that come together and form an even larger compound. The hallmark of a synthesis reaction is that there's only one product, and it must be a compound. Here's an example of one of the synthesis reactions you guys saw a video on, where sodium metal it comes together with some chlorine gas and forms sodium chloride in its balanced form. You have two atoms of sodium for every one molecule of Cl2. You can see there's two atoms stuck together for each molecule of chlorine. And when those numbers come together, they form two molecules or units of sodium chloride. In the synthesis reaction, energy is produced. You may recall that most of those synthesis reactions, heck, I think all of the synthesis reactions you looked at kind of looked like there was an explosion going on. Usually heat is produced, sometimes light is produced. They typically give off a fair amount of energy. Decomposition reactions is breaking a reactant up into smaller products. Frequently, those smaller products are individual types of elements, but they don't have to be. The hallmark of a decomposition reaction is that there's only one reactant. So this is kind of opposite of the synthesis reactions, and that synthesis reactions have only one product, and decomposition reactions have only one reactant. Here's an example of a decomposition reaction where water is broken up using some electricity, and for every two water molecules that are broken up, you get two molecules of hydrogen gas and one molecule of oxygen gas. You can see there's only one reactant here, and it breaks apart into two different products. In a decomposition reaction, you have to put in energy to break those things apart. Energy is always used in a decomposition reaction. It could be used in different forms to make that reaction happen. Sometimes it might be heat. I think the reactions you saw videos of, they used heat. The example on the previous slide was breaking apart water using electricity. So a variety of means can be used to break that individual reactant up into more than one product. So I'm going to have you guys do a quizzes that kind of sums this material up. And you might want to refer back to the PowerPoint that I'm going to post that's essentially this video without the narration. And you might want to look back at your document and make sure you've completed all the parts of that.